Hi everyone, just another quick update. I have a small incandescent light bulb there. That's a 2.5 volt flashlight bulb and a small AC capacitor on it just to smooth out the pulses a bit. And I still have my little switch here, and this way here is just the bulb across the coil, and that way there is the bulb with the diode across the coil. And what I'm doing now is just again aligning the coils here, and I'm going to use this my little circuit here that's around, I don't know, 4 Hertz or a little under, maybe 3.5 to 4 Hertz, and I'm going to turn that on. What I have here is I'm just studying the duty cycle, and this works with definitely a really narrow duty cycle, a very small on time. So the smaller the on time and the higher the input voltage is, the better this works. And I'll show you the difference. I don't know if I'll be able to talk much because it might be noisy, because I'll bring the camera close by. I'm going to start the circuit, and we're going to look at what the baseline pulses and everything looks like on the scope here. And really this is the data that's important here, is the volts RMS, and that's across the current sensing resistor, and that's it right there, which is a 0.1 ohm 1% accurate metal film resistor. And we're going to be going with about 50 volts input, and that will be representing our current. This is basically milliamps here. We're going to be under in the small milliamps. Polarity is definitely very important. You get this polarity wrong, the diode thing doesn't work. So that has to be set right. And so we're going to flip it on. So it's going to be just the bulb across the coil, and I put that AC capacitor in because I don't know what polarity is. It probably could be going both ways. And then flicking it back the other way with the diode, that's going to show you. And there's going to be a huge intensity of light difference. And what's going to be amazing is hardly does this even glow when it's directly across the coil. And now when we put the diode across it, now this bulb here just, you'll see how, it's bright. So for every pulse. And what we'll see is when we get back here, when I flip it on the diode, is we're going to see the same amount of current used as if it was open coil. So that's what's really interesting. So basically we're putting a load on the primary coil on this secondary coil, and it's not reflected back to the primary coil. And this is to study one piece at a time here of what Tin Man is sharing with us. So this is why I'm doing all these tests, to better understand how his device is operating. So let's start it up. So the pulses are there now, and I'll put that is center position. It's open coil right now. So I'll keep that inductor line there centered. It kind of keeps itself there, but I'll hold it. And let's look at our baseline current there. That's what we are utilizing right there. So about 194 millivolts is measured across that shunt there, and that's what it looks like. And this is our times division right there, 2 milliseconds. Previous videos I was saying microseconds, and it's obviously milliseconds. So now I'm going to flick the switch so that we've got the bulb on. Now you hear the pulse goes down, open coil, and now the bulb is across the coil. And if we look at the bulb, we're seeing a very faint little glow. Okay? So now we're going to go look at our current. and our current has gone up. Okay, so we're at 230 millivolts across the coil, and that is the pulse there. Our time division is identical, hasn't changed. So that's normal transformer action. So the load is reflected back to the primary on the secondary. And now we're going to flip to the diode. And I don't even have to bring the camera close. You can see the difference in intensity. And very clearly. And now if we go back and we look at our data, we're exactly at the same input as we were. 193, 194 millivolts across our shunt. And that's it. So I'm going to flip it. I'm going to leave you the camera there. Okay, I'm flipping it to open coil. That's open coil. And that is with the bulb across it. So using more current, open coil, open secondary when I say open coil, obviously. And that is now the bulb across it. So I think that's about all I wanted to share, and I think that's kind of interesting, and that'll give me better ideas of what needs to be done. What I'm thinking of doing next is I've made this, I've readjusted all this, and here I can put a 1-inch neo magnet underneath there, right on the core. The core of that coil is coming off here, and I've got these nice N52 1-inch neo magnets here. There's one of them. Very powerful thing. And what I'm thinking of doing now is basically with the magnet underneath there, we won't need to energize the coil to pull it in. Basically the magnet will pull in the core, and when it gets stuck in the center here, that's when we're going to just give it a tiny little pulse, or as small of a pulse we can, basically to free it out. Okay, but what's going to happen is when we do give a nice little tiny pulse, is our bulb is going to light and take. So we're doing a transfer of energy at no cost, to me it doesn't seem, to the primary coil. No cost of extra current. So that is what is going to be the next test. Thanks for watching. Bye now.